All right, our Explore section, we're going to break into 3 videos. The first video is going to cover parts A and B. Problem 4.3. Statisticians measure the length of a linear correlation between two variables using a number called the correlation coefficient. This number is a decimal between -1 and 1. When the points lie close to a straight line, the correlation coefficient is close to -1 or 1. When points cluster close to a line with a positive slope, the correlation coefficient is almost 1. And with a negative slope, the correlation coefficient is almost -1. So what that means is if the line is going up, it's going to be almost 1 or a positive 1. When the line is going down, it's going to be almost -1. Points that do not cluster close to any line have a correlation coefficient of almost 0. So if they're close to the line, it's 1. If they're not close to the line at all, it's 0. Positive association with correlation coefficients greater than 0, while negative association has correlation coefficients less than 0. So you're looking to see again if your line is positive or negative, going up or down. In part A, the first question says, the graph below has a correlation coefficient of 1.0. What do you think a correlation coefficient of 1.0 means? So what does it mean that this line looks like this? What does that 1.0 tell you about the line? Number 2, which of the scatter plots below A through F has a correlation coefficient of -1.0? What do you think a correlation coefficient of -1 means? So you're taking a look at these 6 scatter plots, seeing which one has a -1 correlation coefficient. Remember, this one had a positive 1. Which one would be the -1? Then after you're done with that, match the correlation coefficients -0.8, -0.4, 0.0, 0.4, and positive 0.8 with the other 5 scatter plots. Explain your reasoning. Remember, we said if it looks like there's no association, it's closer to 0. If it looks like there's some association, it'd be either closer to 1 or -1. So you just label them right underneath the graphs. Which one do you think fits? Part B, when you inspect a scatter plot, often you're looking for a strong association between the variables. The scatter plot below shows the relationship between the top speed of a roller coaster and its maximum drop. The pink dots represent wood frame roller coasters. The blue dots represent steel frame coasters. So here's our graph. Maximum drop is on the X, top speed is on the Y. Suppose you drew one linear model for all the data in the graph. Could you use the model to make an accurate prediction about the top speed of the roller coaster with a given maximum drop? And explain. Now remember, a linear model would be a line through the data points. I think I would draw my linear model here to look something like this, or maybe like this, somewhere around here that looks like it goes in between the data sets or data points. Number 2, estimate the correlation coefficient for the top speed and the maximum drop. Is the correlation coefficient closest to -1, -0.5, 0, 0.5, or positive 1? And number 3, is the maximum drop of a roller coaster likely to be one of the causes of the top speed of the roller coaster? So based on the drop, what does the drop tell you about the speed?